Today we are finishing the 7th set of notes, so we're going to be on the back side of those notes. This is the second day that we're working on these notes. So basically at the top of the page there's two theorems that kind of talk about the idea of complex roots or roots with square roots. So basically what all of that is just saying is that if you have a square root in your answer, there's always going to be a positive version and there's always going to be the negative version. And we know that from quadratic formula, or it's taking the square root method, that whenever you take the square root, there's a positive and negative version. Similarly, we get an I in an answer from taking the square root of a negative number. So that rule also applies. If there's a positive I, there has to be a negative I. So as far as when you go to do solutions or whatnot, you'll never have an odd number of complex solutions or an odd number of square root solutions. It's always going to be in pairs. So with that being said, the first example is just saying that we have this polynomial to the fourth power, and this is two of the roots, and it wants to know what are the other two roots. So we're going to just use that rule and say, okay, well, if I have a positive root 2, that means negative root 2 is another solution. And if I have 1 plus I, the other solution is 1 minus I. So go ahead and try the second one, and when you're ready, just hit play in the video. So for the next example, now we're going to use these answers, and the goal is to write the actual equation from where it came from. So if I have an answer of negative 4, that means it came from the binomial of x plus 4. And if I have an answer of positive 2i, that means it came from x minus 2i. And we know that if I have a positive 2i, I need to add the negative 2i to my list, which means that came from an x plus 2i. So the hint for foiling here, or multiplying using the box method, is that you have to multiply your complex ones together. So this x plus 4 is just going to kind of follow us down. If you do the box, put this on the outside. I'm going to go ahead and just start foiling. So I'll get x squared, and then I'll get 2ix, and then I'll get minus 2ix, and then I'll get minus 4i squared. Now obviously we have to clean this up a little. Notice these middle two terms are going to cancel. I had one positive, one negative. I know I squared is equal to negative 1, and that's something we learned earlier in the year. So this negative 4i squared is going to become a positive 4. So now this whole ugly problem with all these i's kind of turned out to be a nice real problem. I have a real value of 4. Now I box with this, or foil with this. So I'll get x cubed plus 4x plus 4x squared plus 16. And all I'd ask is that you'd put it in standard form, and that means just in order with your exponents. So if I were to solve this equation, I would get the answers, or the solutions, of negative 4 and plus or minus 2i. So you are able to work backwards. So we're going to do that last one together. The last one is a little bit more difficult and involved, and you'll see why in a moment. So we're going to start by setting up our binomials. So the quartic equation has roots of 8, 2, and 2 minus 3i. So I know I can add a 2 plus 3i in that list. So a positive 8 comes from x minus 8. Positive 2 comes from an x minus 2. And then here, this 2 minus 3i, I have x minus 2 plus 3i. And then x minus 2 minus 3i. So notice what they had in common is that 2 is negative both times because it was positive both times in the actual solution. So again, we're going to have to foil. My boxers, if you're doing your imaginary, the 2 on the right hand side, you're going to make a 3 by 3 box. Foilers, I'll show you how to do that in a moment. If I multiply these real ones, so let's do the real quick, and again you can do the box for that. I'd get x squared minus 2x minus 8x plus 16. So this trinomial becomes x squared minus 10x plus 16. Alright, now, to do the second one over here, we want to be kind of organized again. If you're a boxer, yours will be very organized. You have each term in a box and your like terms will be on a diagonal. So you don't have to worry about organization. It kind of does it for you. For FOILers, so we're going to start by taking the x into all three terms. So I get x squared minus 2x minus 3ix. And now I'm going to take this negative 2 into all three terms. And the key is when we start doing this, you want to line them up under their like terms instead of writing this all in one long mess. So negative 2 times x is a negative 2x. Negative 2 times negative 2 is positive 4. So I don't have any constant terms yet, so I'll start that column. And then negative 2 times negative 3i will be a positive 6i. And again, there's nothing like that just yet. Now I'm taking the negative 3 into all terms. So 3ix, I got a positive 3ix. 3i times negative 2 is a negative 6i. And 3i times a negative 3i is a negative 9i squared. And now notice it's nice and organized and we can combine like terms. So kind of turn this into a big addition problem. I have x squared minus 4x. These two are going to cancel. Then I have plus 4. Again, those are going to cancel. And then I have this minus 9i squared. But I know I squared is equal to negative 1. So this is going to become positive 9. Then I need to add the 4 to it. So this will be x squared minus 4x plus 13. And then the goal is I need to still multiply it with this other trinomial of x squared minus 10x plus 16. So again, my boxers, you're going to make another 3 by 3 box. My FOILers, you're going to go ahead and multiply it out and be organized with it. So I'm not going to finish this problem, and in a moment a question will pop up for this, asking for the solution for this. So go ahead and pause the video so you can do the work, and then when you're ready, hit play and you can input your answer. Other than that, that's all for today for the 7th set of notes.